Hi, welcome back. In the previous two episodes, what we have been focusing on is how to deploy our application. The first deployment was we deployed to a hosting website. In our case, we used Firebase hosting. You can use GitHub Pages, or you can use Netlify, you know, or you know, or S3 buckets, whatever, right? And then in the last episode, what we did was this: we took a slightly different way of deploying application. We combined our application, our Angular application that we built, with reverse proxy. In our case, we used Caddy, and we created a file, a Caddy deployment file, and using a Caddy and the deployment file and our Angular artifact, we we built an image. We built a Docker image. We then push the Docker image to the Docker Hub. You can now use the Docker image, to deploy the application to your Docker host. You can also use a doc your this Docker image in in Kubernetes, which is what I've shown. So if you haven't seen that, go back to the previous episode, which is episode part 16. Okay. In this final episode for this entire series, what I'm going to do is this: I will now take our Angular artifact, take the artifact, and embed it into a binary file, so that when you run the binary, uh, which is the HTTP server, the binary will serve the our our Angular application, right? So what we're going to do is this: we are going to convert this into a series of into bytes, and then we are going to build our HTTP server using Golang. We will use just the plain old HTTP package module from the net module, rather than using something like a framework like Jingonic, or some other web framework. Let's start. As usual, we will create a new branch. I will call this part 17. Okay, let's make sure we got part 17. And now, to start off, what I will do is I will build the Angular application first. Okay, so rather than using my global ng build, I'm going to use the ng in the node module directory here. Okay, here ng. And the reason for this will be obvious afterwards when we write our makefile. Node modules in ng build. So we'll build it for production. So we add the prod flag. Okay, I will pause and I'll come back when Angular has completed building. Okay, right, it's almost completed. Complete the build. The entire build took about a minute, and after that build, what we have is we have the this directory, the distribution directory, and inside the distribution directory we will have another directory called front end, which is our Angular application, and inside front end, that's our artifact, right? So this part here, all these files, is this thing. What I will do is this: I will go into the deployment directory, and I'll now copy those files over front end. From the front end, I'll copy the entire directory over. Okay, so we have this thing here, and what we'll do now is this: we will now start building our Golang application, and the version of Go I'm using is 1.15. I'll start off by creating a module. And then I'll just go main first. I need to create a file first before I can start packaging this. Right. The tool that I'm going to use to convert my front-end directory into into a series of bytes is this tool called Packager. There are many tools that can do this, right? I'm just using this. Okay, you can find it under mark-based packager, and this is what I'm going to do. Install the command. You need to install the command first. Okay, now you can do packager dash dash include, and then you say front end like that. So what happens now is this: it has generated a file called package under the same package as my main file. That's my main file. The package is name. So if I look at package go, this is the file that has been generated, and all this stuff here, all the bytes here, this is the contents of my directory. Okay? So we can now go ahead and build our application. So I'm going to import flag. Flag allows me to pass command line. What I want to do is that I want to allow the user of this of this binary to be able to set their HTTP port. And this is what I'm going to do. Port. I'll say flag. The port number is an integer. The option is port 8080. I'll put a message. HTTP. Can say set HTTP port. Default is 8080. Okay, and now I will pass the port. I'll pass the command line like that. Okay, so this one just reads the command. You can have, later on, you can take this and you can customize this, by adding more flags. I'm just going to have one flag. The second thing I'm going to do now is I'm going to create a HTTP file server from this file. Okay. The way I'm going to do this is we will mount this file as a directory, and then we'll pass the directory to the HTTP file server. So I need two package. The first is the net HTTP, okay? And the second is the mark-based directory, the one that we use. So I need to import that packager. I need to go GitHub. That's the package. Those are the two packages I'm going to need. This is what I will do. Right, I will go HTTP file server. We'll create a file server. So the file server takes a file system, which the packager will allow me to do. So this thing will return a file system, and then all I need to do is just say front end. This is the name just now that we when we bundle. This is the name that we gave just now, and this file server will return a handler. Now we will take this handler and we pass it to the HTTP handler. This handler. So this handler takes two parameters. The first is a string. What we'll say is this: any path that starts with a slash, okay, will be handled by our handler. So essentially, we are done. Okay, that's the entire application. Now we need to start the server. I'll create an interface, and I'll say we'll listen on all the connecting ports, or on the connecting network interfaces, and then I will pass it the port, right? So this one says I'll just create a string. It's basically just a string of four zeros. Listen to all the ports available on the local machine on this port that we provide. Okay. Now we probably want to just print out a nice message to say that I'm starting the server. Say log printf starting HTTP server on port. Okay. And this is how we start it. We just go HTTP listen and serve, right? And we'll pass in our interface. And then I'll say nil here. The listen and serve takes two parameters. The first is what's the port, and the interface to listen to. The second here is the server. We can actually create our own HTTP server. By passing a null, what I'm saying is that I'm using the default HTTP server, which is what I'm doing. I'm configuring the default HTTP server here, and then I'll check to make sure that there are no error. Okay, so this is a rather unique Golang syntax, right? And this error ERR is scoped to the if statement. If there is any error, in other words, if error is not nil, means we have an error. We'll just go fatal. We'll exit. Okay, cannot start HTTP server. Okay, error, and then we'll just display out the error. So maybe the error here, I'll put uppercase. That's it. That's our entire application. So let's test this guy. We're going to deploy. Okay, so we can go run. So the HTTP server is started. Let me just do a clear, put here in front. So the HTTP server is started, and we can now is listening on port 8080, and we can now test it by just going localhost 8080, and you will notice that it's being served from here. We can also try it here. 80. That's the server. Just to make sure that we are not serving from the from our application. What I'll do is I'll delete the cache. So remember, we install a service worker, and I also want to disable the service worker, unregistered service worker. And this is the application, right? So it's being served from here. I can also change the port. So I can say port. Let's listen to port 5000. Right. So now it's listening on port 5000. I'll change this to port 5000. Okay, it's being served from port 5000. So what is a little bit unnerving is that we are not sure that it's actually being served from here. So let's go ahead and add some logging every time when it serves a request. Our binary will display some logs, right? So what we're going to do is this: we are going to intercept requests coming into the default HTTP server, and we will capture information like what's the method, the URL. We'll display that, and then we'll forward the request over to the HTTP server, and get the HTTP server to perform. So this is what we do. Okay, so let me repeat that again. We will create our own handler. When the request comes in, our handler will intercept the request. We will then log the information. We will get information from the request, and we'll log it out to the console, to the terminal, and then we'll pass the request forward to the HTTP server, to the default HTTP server. This is what we do. Okay, we will create a function called logger. Logger will take a handler, the HTTP server, and what we do is that we return a wrapped handler, our own handler. Okay, so our handler intercepts incoming requests. Sorry, HTTP. Right. Okay. Now we will create a function to handle incoming requests, and the function goes like this. The function takes two parameters. It's very, very similar. The function signature is very similar. If you've done expressed in Node.js, it's very, very similar. The first is a writer, which is the HTTP response writer, and then there's a request. This is the request, HTTP request. This is our own handler, which will intercept the request, and then what we'll do is this: we will return our own handler. Handler func, we will return this guy, right? So we will say our handler will, basically our HTTP server will be handled by this function. Okay, so inside this function, we can now get information like from the request, the method, We can also get information like the URL. Okay. If you want to, we can also time how long a particular request is. Okay. Let's get the time here. You can say start time now. Okay. So we got this information. Now we need to forward our request over to the actual HTTP server. This is the actual HTTP server. So we say handler serve HTTP. We now pass the writer and the request forward. Okay. Now, when the request comes back, we can find out what's the duration of the request by doing this. Now, and then we will subtract it from our start time. And now we can print out the log out the information by doing this. So we will take the first S is the method, the second one is the URL, and the third one is just the time, the duration, and I want millisecond. So sorry, I want millisecond. So which is just this. Okay, right? If you want to, we should also probably log the IP address as well. We can get the IP address from here. Remote address. However, if you take the remote address, you get the IP and the port. As you know, our application. So this one will give you the actual IP, the IP address of the client. The client was making the request. But if you are behind a reverse proxy, then this remote IP address will be incorrect. Okay. So what we really want is that we want to look at the HTTP header to see if there is the X forwarded for. If there is X forwarded for, we will use that. Otherwise, we will use this remote IP. So for that, what I'm going to do is I'm going to write a function. Instead of putting all that logic here, I'm just going to write a function called get IP, which will take a request, and then you return a string, which is my IP address. Okay, and then what you'll do is this. It will first of all from the request header, and then we'll get the X forwarded for. The X forwarded for comes in this format. Okay, so an IP address. So this is the actual IP address, and then if they are forwarded through multiple reverse proxy, then you got other reverse proxy. So the IP address of the reverse proxy here, and IP address of another reverse proxy, right? So proxy 1 maybe. Okay, this is proxy 0, proxy 1, and so on and so forth, right? So this is the IP address that we want. The first thing we do is that we will check this first to see if it's not an empty string. Then what we do is that we will split this thing up. We will split this string up. We will split the IP, the forwarded. Let's call this forwarded. We will split the IP string up based using the comma, and then we return the first element. So for that, we will use the strings module. We will say this: return strings split. Strings. Let me just try. I can't remember what. Let me just check. Yep, strings. Strings. SPLIT split. We'll pass in the forwarded string, and then you do that. So the split will return an array. We'll take the first element, right? Otherwise, what we'll do is this: we will return the remote address. The remote address gives us the IP colon the port. So let's split that again. We use a string split to split it and just return the IP portion. Okay. Okay. And now we will just go IP equals to get IP. We'll pass in the request. Okay. Let's do that. This is the IP address. And then we will say the IP is here. Okay. Let's try running this guy and see. Right. So we will now try to load this again. Let's unregister this. Make sure that it's serving from, make sure that it's not serving from storage. One thing I don't like about Firefox is that you just cannot delete the entire cache. You need to go through one at a time. Okay, so let's try this 5,000. Oh, did I restart? Oh, sorry. I know why it's not working. We have created the logger. We haven't actually used it. So this is how we use it. We go logger. Okay. So previously it was nil, which is using the default server max, the default server max. So now we'll say we'll use our own server, our own handler. We'll pass in the default serve max into here. Right. Then we get the information, get all our information. Then we forward it to the default serve max. Let's show this guy. And then we'll start again. Let me save this first. Okay, so let's start this again. Right, so let's reload this. Hopefully we will be able to see our request. So there we go. That's one of them. Let's try that again by deleting all this. Okay. So now we can actually see the request our method, the call that the IP address of the client. Let's simulate a call from behind a proxy server, from behind a reverse proxy by doing this. Our thing is 8080, right? And then we'll just say X. Let's call this 192.168.0.1. This would be the actual client, and then okay. Oops, not 8080, 5,000. Okay, so now we actually get the IP address of our reverse proxy. One final thing before we finish is we would also like to return the status code. Okay, and to do the status code, we'll apply the same technique. However, this time, rather than intercepting the HTTP request, we'll intercept calls to the writer, to the response writer. Okay, in the response writer, there is a method called write header, which actually the default serve max writes the header. What we'll do is that we'll intercept this call. We will capture the status code that's written, that is written, and then we'll again do the same thing. We'll forward the call over to the actual write header. To do that, what we'll do is this: we need to create a type. Okay, we need to sort of subclass the response writer, since and the way Golang actually go about subclassing the response writer is through a struct. Golang is not really an OO language, but you can do subclassing this way, sort of subclassing this way. So I'll call this type my own type called wrapper. Okay, if you are coming from an old background, think of this struct as as your class. I'll call this wrapper response writer, which is of type struct. Okay, and then I will say I will inherit, quote unquote, I will inherit from the response writer. I will inherit all the attributes or all the methods as well as all the members. Okay, quote unquote. And then I will add my own member property. I'll call it status code, which is a type integer, right? So now what I'm going to do is I'm going to override the write header method, and the way to do that is to use in Golang to use something called a a a function, a handler, using a handler. So you give this thing a name, and then you go wrapper, and so the name of the function must be the same. So it's write header, and then we will say status code int. So let's look at this again. This is the method write header. You must match this, and this is the status code of type int, right? What this is this little thing here allows us to says that this method, okay, is sort of attached to this structure, and for this method to access the contents of this structure, like the members, we'll use this thing that is exposed here, the little w. Okay, so now the status code comes in. We'll go w status code. Okay, this is called a receiver. Sorry, this is called a receiver, right? A function receiver or a method receiver, and then we will assign it over to status code. Now we will forward the response writer to the actual writer, like that. Okay, so this is sort of like the Golang way of overriding a method, extending a class and overriding a particular method, right? By using a receiver. Now, instead of using the actual writer here, we actually passing the actual writer. Now, what I do is I'll create a wrapper, my own class, response wrapper, and then I'll pass in the writer. The response writer, and I'll pass in the writer. So what I'm doing is I'm creating the object, or instantiating object, if you like, and I'm passing in the original writer. I'm assigning the original writer, this writer here. Okay, I'm assigning it to the attribute called response writer. So when the default marks calls write header, this method gets called. We intercept and we save the status code, and then we forward the call over to the actual writer. This is like a super. Here we are calling super. Now we'll use wrapper here. Instead of using writer, we use wrapper here. Okay. So once this thing comes back, we have the status code. We can now print the status code here. This wrapper status code. Okay. So let's run this guy again. Okay. And now if I do this, notice that I now have the status code. And if I give something that it doesn't have, I should get a 404, right? And now if I load from here, I should have the status code. Notice that this is 304 because of the cache. HTTP because of the caching, right? So I'm getting a 304. Okay, so we have taken we have a few short line of Golang. We have created a single binary. Well, we haven't done a single binary yet. So far, we've been testing. We'll now compile it into a binary by doing this. Go build, right, and then we can give it a name. Let's call this FE for front end, minus O FE for front end, and then we'll say build everything from here. Okay, so that's our front end. FE, that's the binary. Now we can go FE. Let's listen to port 8080. Well, let's say 8000. Okay, and now we can try this 8000. Right. Okay. So that's our binary. One thing you'll notice is this: if I go my binary, okay, notice that is a single binary with with my Angular code embedded in it. However, it is actually dynamically linked. What this means is that, well, it's a single binary, but it's not really independent. The reason is because it is linked. It is got. It is dependent on the libraries of the operating system. So if we can look at the file, uh, let me just close this guy here. Look at this. These are the files, or these are the libraries that FE, our binary FE, is dependent on the local operating system, right? What we want to do is that we want to statically link this library, and the reason why it's actually using this is because the HTTP package uses the what Golang called the seagull receiver, the C the interface between Go language and the C library, the that interface, that library. What I want to do is this. So that creates some dependency in the local, to the local operating system. To do that, to build a truly standalone statically linked library, we want to remove that dependency. So we can do two things. We can either ask Golang to disable Seagull when it's doing compilation, or we can use the netgo's version of the resolver rather than the C version of the resolver. Okay, so one of two ways. We will use the disable Seagull. So I'll show you both of them. To disable the Seagull way, what you go Seagull enable. We disable it. You set the flag enable, and then you just go build, right? OFE like that. And then now we go LDB. If you look at LDB again, you notice that it is now a statically linked code. That's one way of doing it. Another way of doing it would be to use to select the uh, the 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 Go version of the resolver. So that would be netgo. So let me just go get first. Oh, okay, right. So this is the Go version, and again, if I go file FE, notice that it's statically linked, and then again LDB. Okay, so uh, one of two ways, and then you can go and Google up, Google to find out, what are some of the differences and when you should use what. So I will not discuss that here. So now we know a way of this building, an executable, and just to make sure that it still run, the statically linked code still runs. We can go FE, right, and then we can go 8080. Make sure that it is still running, right? Okay, so now we will create a make file to actually build the whole thing. Let me remove the binary. Okay, so I'm going to create a make file, and then we will build Angular first. The way we're going to build Angular is we'll remove the current directory, the Angular directory artifacts. Okay. After that, what I'll do is this: I will cd over to the front end, to the other directory, and I will use the node modules. And these are for for people who are using this but may not have Angular, the ngCLI installed globally. I will build. Okay, right. After that building, we've got this directory. We'll now copy this directory front end over to deploy front end. Okay, let's try this and to see if it works first. This target, go make Angular. Again, let me pause this. When it's done, I will resume. Okay, actually, I don't need to pause because it's actually going quite fast. Right. Okay. So our target, this target works. Now, what we'll do is this: we'll build the Golang. I'll call the target called Golang, and then it will be dependent on Angular. It will be dependent on Angular. And the way I'm going to do is this: we'll run the packager first. Okay. Front end. I've shown you this command. Okay. So when that is successful, what we will do is this: we will go build -o. We'll put it inside the bin directory. What we'll do is that Go actually allows you to build for different operating systems. There's one really cool thing about Go is that it allows you to build uh, for different operating systems, like for OS X or for Windows. And what you want to do is this, and the way you say which target you want is this. You say there's a flag called Go OS, so I'll build it for Linux, and then what architecture, so Go Arch AMD64. This is for the Intel architecture. Alternatively, you can have AM for you can have other architecture like PowerPC, or what have you. And then so I will say here FE. I'll put the name of the architecture 64, and then I will say Linux. Okay, so it's going to build into that, and then I'm going to enable the tags. I'll use netgo to build a statically linked library, and then my source, I'm going to put this. Okay. Okay. So let's build for the three main desktop, for Linux, for Windows, and for Mac. So this one I will say I'll substitute Linux for Windows, and this guy here I will substitute that for Darwin, which is Mac. Okay, I'll remove this. So the end basically says that when this is successful, then execute this. If this is successful, then execute this. Right? Which I should probably also do with the Docker here. Okay. Right. Okay. So let's try building this and see what happens. So we'll go make. We will first of all build Angular, because Golang. This is if you don't say anything when you do a build, since this is the first one, it will build this. And since Golang depends on Angular, you build Angular, and then you come back and build this. Yeah. Okay. So now it's building the Go. And it's done. So let's go and have a look. Let's go into bin and have a look. Right. So these are my files, and if you notice, This is the Windows executable. This is the Mac, and this is Linux. It's not strip. I can probably add a flag to strip it to make it smaller, or you can go strip. Okay. So this is the end of this app. So now we can run this before I end. We can run this. We can go AMP. Obviously, I can't run Darwin or Windows. I can run Linux, right? So it's running on port 8080, and now I can go here. This is the port 8080, and we get that. Okay, so I've shown you. So this is the last episode in season one, where we deploy our application as a standalone binary. Uh, so we have actually completed our front end in season two. In the next season, which will begin, in a couple of weeks, uh, we will look at building out the back end using Nest.js. Okay, and we will bring those two together into one single application. Till then, stay safe, and I'll see you again.